So what we're going to be looking at here is this thing called inverse binomials. It's basically a way that the CAS can help you to solve problems where you're trying to figure out how many trials are needed on a certain event to get some probability of success some number of times. Basically, your question will look something like, how many trials this event has a probability of 0.2. How many trials do I need to have a 95% chance of 10 successes? They'll tell you how many successes they want. They'll tell you what the probability is, and they'll tell you how much probability you want to achieve. It's the number of trials needed for a certain probability of some number of successes. When it's doing this, it's important to remember it goes from the left-hand edge. So it will tell you the minimum number of trials such that the probability is less than or equal to the given cumulative probability. So if you want more than or equal to, then you need to find the complement. If you get the inverse binomial n feature up on the CAS calculator, you get a little box that looks like this. Your cumulative, you can find it by pressing menu, then pressing probability number 5, then distributions number 5, and then you can scroll down, you get to inverse binomial n. Alternatively, you can just press the D key. Either way, that will get you to this box. Let's see what this looks like in an example. I've got an example here. Monique is producing she's practicing her goal shooting for netball. She knows from experience that her chance of making any one shot is 70%. So I see that's the chance of her achieving her goal. She plans to practice until she scores 50 goals. So we know that our probability of success our number of successes is 50. We need to figure out how many shots she has to attempt to ensure that the probability of making at least 50 goals is more than 0.99. So got the probability of success pretty easily, got the number of successes pretty easily, but we want the probability to be more than 0.99. So if we want the probability to be more than 0.99, then that means that our cumulative probability, that told us what we want a value. We have that value before and up to. So we need to use the complement for this. And so if we put those in, if you do invin on m, you get 0.01, with 0.7 and 50, you end up with 86, which is the correct answer. And it's a lot easier than going through